Question here, like not, is you can look at, so if there's a rule, there's a general rule about this situation, right? What's this? X to the fourth, right? The general rule is if they're the like bases and you're dividing, you subtract the powers. That rule, that's all it says, because that's all it is. It doesn't care. So if we've seen stuff like m to the 2x over m to the x. What would that be? What's the rule? M to the x. Because what do? Like bases, subtract the powers when you divide. Right? Everybody with me so far? That's good, because there's less to memorize. You memorize that one thing, when you divide like bases, you subtract the powers. It takes care of every problem that looks like that. Not something different to memorize for everything. So, the question right now is, if I have this,
X time?
Yeah, why? Two reasons why. You've got the official, by the textbook, way, which is what do you do with powers when you have like bases you're dividing? You do what with the powers? Subtract them. All day long. I love some of you guys are like, well, then you make it 10. Well, what's 7 minus? That becomes x to the 7 plus 3, right? Mm-hmm. Minus a negative is plus. Which becomes x to the 10th. I really hope everybody could possibly see this. That is equivalent to bringing these up and making them positive. Right? Negative means flip. But when I make minus and negative becomes positive, that is what it looks like.
If 7 was negative 2, how would you do it?
Same way. So if you do this, now watch this. Let's do it by the book.
Yeah.
So this is x to the 10th, no matter what way you look at it, right? Yeah. By the book, this would be x to the negative 7 minus negative 3, which is x to the negative 7 plus 3, which is x to the negative 4, which is 1 over x to the 4th. I love it. Right? Okay. How would I do it? I would flip those. It becomes x cubed over x to the 7th, which is 1 over x to the 4th. Thank you very much. Right? So my way is not an alternate way. It's just allowed through the rules. Negative power is being flipped. So that's why I do that first. Bless you. And then 3x's cancel with 4 left on the bottom. Both answers agree. So the textbook way to do something is never wrong. It's just not always the best way to do it. Right? Does that make sense? So it's a good question about, I'm not really adding these powers. It becomes addition because I'm subtracting the negative. Dividing like bases means you subtract the powers, but when that's negative, it becomes plus. Of course it does. Yeah.
So, like on the first example you wrote, if there was a coefficient in front of x to the negative third, does the whole thing go up or just x?
So, if I have, let me make one like that. If I have like m to the 8th over 2 m to the negative 5th. What makes things flip? Negative powers. What is being raised to a negative power? M. Not 2m. If you meant for 2m to be raised to a power, you better put 2m in parentheses. So yeah, powers are powerful, but not that powerful. They can only affect what they are on. What's on the 2? There's the first power up there. Of course there is. Understood to be there. Does that make sense? Yeah. So here, both of these would flip. Because they're both being raised to negative power. Now, of course, the 2 would also get raised to the 5th power. But here, only the m's go up. So what does it end up being?
M to the 13th over 2.
Yeah, because these 5 m's go up. So then you end up with 13 of m's up top. So you don't say that's connected to that. It is connected through multiplication, but division can kill that connection very easily, right? And the negative power is related to division. That's why that goes to the other side. This is not negative power. It's not going to go to the other side. I like it. Yeah.
For the second example, can't you just like leave the 1 out and then just subtract the exponent?
You mean this one?
Yeah.
What one are you talking about?
The 1 over x.
Oh! All right, well, what do you get when you subtract powers?
X over 4. X to the 4.
No. 3 minus 7 is not 4.
X to the negative 4.
Which becomes this. Right? You don't stop at a negative power. That means you have something still to do. You flip it, yeah. I like it.
So then when we have like those stupid long questions, if there's like a negative exponent, might as well move it first thing before.
Shit, yes. All right, here. Let me give you a stupid long problem. Because you know I'm going to give you some more stupid long problem. Are you talking about something like this here? Let's not make it eminent. Yeah.
Yeah.
Yes, sir. What's up? Oh, just a minute. All right. So this, real quick. This guy becomes 1 over 2 to the 5th. And then what's 2 to the 5th? What's 2 times 2 times 2 times 2 times 2? 4 times 4.
32?
Yeah, 32. So 4 times 4, 16 times 2, 32. Right? This would be 32. So what I did was I flipped it, and then I 5th powered it. Yeah. Just a verb, a phrase. I like it. I like this problem so much. If you try to do the whole thing at once, you're insane. And that's part of what your brain tells you. I have to be able to do this whole thing. The way I look at this problem is, it is 4 over 10. That is what the problem is at the moment. That's easy as shit. Yay. So, I'm not trying to come down on you if you have trouble with these kind of problems. Break it into parts. Do the numbers, and then do the letters, right? So first thing I would do is, 4 over 10 becomes? 2 over 5. Not negative 6, right? And don't say, well, you're going to subtract the... No, there is no 8. There is no 2. Right? This is just 4 over 10. Look at all. It's 2 over 5. You reduce it. What would I do next? What do you guys think I would do next? Dance? Is that what you said?
The M's?
Oh, the M's. I'm sorry, Kelly, you said dance. I'm like, you don't want me to do that. So what happens to this guy?
Goes down.
Goes down. And what else moves? So the next thing I would do is, like somebody said earlier, like you just said, I think, a minute ago, when you have a stupid long problem, what's one of the first things you do? Move all the negative powers so you don't have any negatives. That kicks ass. If you had a problem with a lot of negatives in it, wouldn't it be great to get rid of them? All right, let's get rid of them.
Quick little side thing. What if the top and the bottoms were negative?
Then they both flip. We had a problem like that just a minute ago.
Oh, yeah.
They just both flip. This guy wants down, this guy wants go up. All right. I like it. So let's see, what do we end up with? What's on top here? The 4x's stay there. Those 3 come up. On the bottom, those 5m's are still there. Those 8m's came down. Those 2 z's are there. And those other 2 z's come down. See, I'm not caring about this negative 2. Because that's on the outside. It's the last thing to do. Order operations. Don't I do inside first if I can? Yes. I'm still working on the inside. And now it's easy. 2x to the 7th over 5m to the 13th, z to the 4th. Now what 2 things does that outside power tell me to do? Flip it. So I do that first. Just straight up flip everything. And I still have to square. I like it.
I think you just issue 2.
Not, yeah, just square everything, right? So finally that becomes 5 squared, 25. I don't need this anymore. M to the, no? 26. 2 groups of 13 m's, 26 m's. You multiply powers when you raise a base to a power, right? Raise it to a power, z to the 8th over 4, x to the 14. Bam. So I do have colleagues where they bring the -2 in first, and it just makes it so disgusting. I'd rather decrease the amount of shit that I have to do this to first. That makes sense to me. There are other ways to do this problem. This is the way that makes the most sense to me.
So when they're negatives, you bring them down, they're negative in the bottom.
Yeah, negative power means flip. So wherever it is, it wants to be on the other side. Yeah. And just to show you, I mean, how many x's did we end up with in here? 7. Right? And what is 4 minus -3? 7. See, so moving it up takes the negatives out of the way. You're mathematically going to get the same answer, but I've taken the negatives out. And negatives are one of the big places we can make mistakes. That's why I say to do this. Okay, I like it. Maybe. Nothing wrong with just, like here, what's -8 minus 5? -13. So then you would flip it down. See, I mean, so it matches with what I got. It's just that I think my way is easier. But you can do it either way. If you do it correctly, you're going to get to the right answer. Just do it correctly, please. Anything else? Anything about that problem or something else? This is going to be a quick class. Yes?
Just like on the practice test, the first one, 1b, 3/5 to the -2nd power.
Oh, yeah. So what's being raised to a negative power?
3/5.
Good. So what do you do? What's negative power mean? You gotta love that shit. So it makes total sense. When you have a fraction, the idea that negative power means flip. You flip it. And then you also have to do what? So I flip it, and I still have to square it. You gotta love that. You don't have to, but you should. I mean, that's really nice. Negative power means flip. That's all it means. A negative power cannot change the sign of a number. It can't. What is -2 to the -1?
2.
No.
-2.
-1 times -2 is 2. What does a negative power mean? It only means flip. 4-letter word starts with F. You can say in mixed company. So what am I flipping? No. I'm flipping -2. So it becomes 1 over -2. It's still negative. If I had an operation that said it just flips something, can that make the sign change? No. If it's -5, it's -1/5 now because it flipped. It cannot change the sign. So the biggest mistake I see is people say 3 to the -2 equals -9. Makes no sense. You flip the 2 3s, now it's 1 over 9.
That's exactly what you had in the quiz there. I didn't put the negative, I got marked 4 points off.
Shit. Yes.
I would like to ask you about matrix. The one
The
also-
matrices, okay.
Yeah, matrices. Yeah.
Yes.
Do we have to go by column, or
As opposed to what?
for example, in this equation, like we have 3 letters. For example, do we have to go like first? We have to make this 1 0 0, and then 1 0 0 0 0 1. Do we have to go like that?
0 1 0. So my suggestion is to go column by column. You can do the columns in whatever order you want to. But if you start to work on a column, finish it. before you move to another column. Why do I say that? Because if you don't, you're going to start losing zeros. And then you're going to make a 0, lose a 0. Make a 0, lose a 0. Right? Some of you guys have lived that experience. Yes? If you've done some of these problems, you have lived that experience. So the way to keep from doing that is to finish a column. Move next. Because once you finish a column, like if you finish this middle column, these zeros, I'm sorry. How do I say this? So let me put some stuff in here. Right? So now, if I finish this column, that means if I multiply this by 9 to add it here to kill that 9, that 0 is not going to screw that 1. Or if I multiply by 8 to kill this, that 0 won't screw with that 0, even more importantly. That's why you want to finish a column before you move to another column. Now, the more comfortable you ever get with matrices, the more you can do things a little more out of order, because you're going to know how to not lose zeros then. But this is the way to just never lose a 0, because that sucks. Of course. Yes?
Can you run through setting up synthetic long division?
Sure. Oh, shit. Yeah, we do new shit, even if people aren't here. So let's see. So let's do one both ways. So if I do this long division, what do I have to do? Cubes, squares, oh shit. So I better put what here? Placeholder. And again, if I have the number 4,605, that is different from the number 465. That placeholder actually means something. So putting that there is going to be helpful. In synthetic, you have to put that there, or else the whole thing goes to shit. You have to have every place represented. That's what it's hardwired on. What gets us started here? What do we do? Yeah, x times what is 4x cubed? 4x squared. 4x squared times x is 4x cubed. 4x squared times negative 2. Change the signs. I love it. Let me make sure everybody's with me. So that's what we got when we multiply this through, right? In long division, the next step is subtract this. So you could write subtract this. That sucks, because I would have to distribute. So let me just go ahead and distribute right away. You just change all the signs, because that's what you would do. You subtract that. You would distribute. So just change all the signs. These cancel like they always have to. And here you get 2x squared. Bring down the 0x. You could, but it's sort of unnecessary here. Yeah, it's going to get on the next step. X times what is 2x squared? 2x. 2x times x is 2x squared, like we just said. You get negative 4x there, and then you change the signs. 4x plus 5. X times what is 4x? 4. 4 times negative 2. Change the signs. 13. Okay. But it's the same thing every time. There's just a lot of unnecessary writing. So can x go times something become 13? No. So you know you're done when this has less x's than this does. Yeah. If this is 13x, I can keep going. So that's why right here, 4x, I kept going. But now it's a number, x can't go into, no, screw it. So now how do I write this? Plus. Okay. So what's the unnecessary shit? Do you see how this is going to cancel every damn time? So that's unnecessary. So that's the first thing synthetic really does, is it doesn't make us write that shit down. And it also changes the sign at first, so I don't have to do it every time. So what would the synthetic look like?
2.
2. Yeah. This guy changes sign. And then I'm going to have 4,
Negative
6,
0,
0,
5.
5. Because they don't have any x's. They're going to represent that. And then you bring the 4 down. 2 times 4 is 8. Add. Multiply. Add. Multiply. Add. Negative 6 plus 8 is 2. Negative 6 plus 8 is 2. 0 plus 4 is 4. 0 plus 4 is 4. 5. I mean, so that method focuses on the most important parts. It takes the variables out of the way, just like matrices do. This is better than matrices, though, I think. Even if you don't fully understand, like, yes, that's better. Yes. Where? Oh, you do the same thing, except here it would be 4 times negative 2, negative 8. Negative 14. You still multiply and add. Still multiply and add. Yeah.
Do we have to do both?
Only if I say so. If I just give you a problem, I say, if I just said, do this, you can do this or that.
But if you say long division.
Yeah, you know I'm going to do that. I got to make sure you can do both ways. Or I could give you a problem. What can I do to this problem to make it you can't do it that way? Or yeah, I could just add a coefficient too. It's that really only works if it's x plus or minus a number. If it's 2x plus or minus a number, it's dead. If it's x squared plus or minus something, it's dead. You got to use long division. Yeah.
But you're not going to do that to us.
I hope not.
Good. I'm still making the test now. Make
How
a
about
note.
one that comes out even that winds up being a polynomial or quadratic or, you know.
Do you mean like with no remainder?
No remainder.
No remainder. I love it. That's an interesting situation. So like, what does that really mean when that happens? So let's see if I can make one real quick. So if I had x squared plus 6x plus 5 over x plus 5. Let me do this the silly way, and then I'll show you the shortcut way. The silly way is actually synthetic division, believe it or not. So let's try it. Let's try it. Here's synthetic division. How does this work?
Negative 5.
Negative 5.
6, 5. I'll bring down the 1.
Bring the other one.
Negative 5. 1. 0. Negative 5, 0.
So what is the answer? It started off as x squared, so now it's
X.
x plus 1. When there's no remainder, that means I could have factored this. In fact, how do you factor this? Now that we know how to do that.
Multiply by 5.
So know this is x and x. What factors of 5 make 6? Or what's the only factors of 5? 5 and 1. And thank God they make 6 when you add them, right?
Yep.
Because I get 5x plus x is 6x. And so what happens here? Look, what happens there? X plus 5 times x plus 1 divided by x plus 5. What cancels? X plus 5. Don't say the x's cancel. I don't see any x's anywhere in there. I don't see any x's. And you're all like, God, how did you drive here? Your vision. But do you guys understand what I mean? There's no x's. There's an x plus 5. There's an x plus 1. There's another x plus 5. So of course these kill each other. So the answer is x plus 1, which is what we got. Holy shit. So when the remainder is 0, that means that you could factor this as this times this. That's beautiful. In fact, put 7 into 21. 3. Remainder,
0.
because 3 times 7 is. So if it goes in evenly, that means your answer times the bottom equals the thing on top. That's what it always means. Yeah, it's really cool.
Will you have one of those on a test?
Maybe.
What would be the right answer?
X plus 1.
X plus 1.
That's it.
All right.
But I'm going to say use synthetic division or something.
I know.
So if you do it this way, you didn't use synthetic division. You see what I'm saying?
Right.
Yeah. Normally I give you some of the remainder so you don't accidentally do the wrong thing and get the right answer. That always sucks.
You want us to do the synthetic division as opposed to factoring it out?
Yes, I love it. If I say so. If I just said simplify this,
Yeah.
you could do that all day long.
Okay.
In fact, that would be the way I'd hope you'd do it.
Right.
Yeah. We're not, chapter 7 is going to focus on this stuff where you factor to cancel stuff out. So I'm not going to give you a bunch of that now. Yeah. Yes?
One eye can go down.
Oh, one. So why did I have to do weird shit for this one? Why couldn't I just divide it easier? Because the bottom has 2 terms, right? If I have a problem where the bottom is 1 term, like this thing, see the bottom has 1 term? You will not get the right answer if you set up the long division. It's just, you can't get it from that. What you do is, what's being divided by 6d squared? This is being divided by that. This is being divided by that. And this is being divided by that. Then you just simplify each chunk. The biggest mistake I see on this prime problem is somebody will go, you do 4, and now the 6 is gone. It's just gone. So this guy is like, I'm still 12. It's like, no, it's not fair. You're to be divided by 6. So it's not fair. What's being divided by this? Everything is. You can't have one guy kill it and everybody else is like, thanks, man. No. Otherwise, it would have looked different if that's what you meant. It wouldn't look like that because right now you got everything over this. So everything over that. And then, of course, that's not the way you end. You reduce each piece, right? Like here. Now you can do this. So this first thing is 4CD. And you keep going. Just reduce each piece. So when do you have to do long division or synthetic? Well, obviously if I ask you to, but also on a problem where the bottom is more than 1 term. Right here, let me see if I can get you guys. The biggest mistake, I can't remember what I said, is I'll see somebody do this. Let me write it again here, just for some reason I have to. They'll do this. Oh, 5 divided by 5. That's awesome. There you go. What's wrong with that? Something we've talked about before that's wrong with this. Division cannot cancel parts of an addition problem. It's not that strong. So see, when the bottom has an addition in it, division goes, oh shit, guys. So then we have to set it up as synthetic or long division the long way around. Here, the bottom doesn't have any plus or minus. Division goes, sweet, this is the shit I do, right? Maybe. You can't break into an addition problem with division. That's not what it does.
Can you finish the last one?
This guy? Wait, that guy? I did. And then 12 divided by 6?
Is
2, the C's cancels. Where's there a D left?
of the bottom.
There you go. 4/3. A C cancels. And these 2 are still there.
Right.
There. That's exactly what you say to yourself. I never bring negative powers in because I don't have to. You can if you want to. I mean, what is 1 minus 2? Right, you see this? Isn't this D to the first?
Yep.
What's 1 minus 2? -1. And then you would flip it and you would catch up to me, right? Whereas I'm just like, just look at it. How many are left? 1. Where? On the bottom. Okay.
Well, D squared is D times D, so it takes away one of those.
Exactly. So I don't have to bring the idea of negative powers in. If they're not there already, I don't have to bring them in. I can just reduce, write the answer where there are more to begin with, because that's where things are going to be left alive.
7B.
7. Oh, yeah. Sorry. So this is the... So I have pennies, dimes, and quarters in 7B.
A roll full equation.
Oh, no. Oh, is this, I might have done that. The number of dimes is one less. Oh, yeah, I gave you one extra piece of information. That was so nice. I didn't even use that last one. Okay. So in this one, 15 coins made up of pennies, dimes, and quarters. So what equation can you set up there?
PDQ equals 50.
Be a lot more specific to me.
P plus
There you go.
D plus Q equals 50.
Cool. I like it. PDQ would be multiplication. The total value is $2.73. So what equation can I write? How many cents do you get from a penny?
1.
1. So I'm going to try not to bring decimals in, because I'm the human. I should be able to control this shit. We made numbers up. How many cents for each dime?
10.
10. How many cents for each quarter? And I end up with how many cents at the end? $2.73. So how many total cents? 273. So if I put everything in terms of cents, I don't have to bring decimals in. So you could write 0.01p plus 0.10d plus 0.25q equals 2.73. But then you see how if you just multiply everything by 100, no decimals. So just do things in terms of cents from the beginning. You don't have to deal with decimals then. And then I say the number of pennies and dimes added together. What's that?
10d.
The number of pennies and dimes, not the money.
P
The
plus
number, so P plus D.
D equals Q minus 5.
Yeah, is 5 less than the number of quarters. And this is another place where you could do 5 minus Q instead of Q minus 5, and the whole thing goes as you have negative quarters. Those are freaky. And then I gave you an extra. The number of dimes is 1 less than the number of pennies. So I was actually, I didn't even use this on my cancer key. To be honest, I didn't even see it. I forgot I was there. But I gave you an extra, now watch, this is really nice. Do you see how you can use like substitution here if you wanted to, but you still got a Q there. So I mean, there's a lot of stuff you could do here. Did anybody try this problem out yet?
Mm-hmm.
You did, I know. Oh, like my front row people. Everybody else is like, I don't know.
I got Q10, P3, and then D2.
Yes. Okay. So I want to point something out. Substitution is more powerful than you think. This one says P plus D is Q minus 5. Do you see a P plus D somewhere else?
Mm-hmm.
Yeah. So you can replace this P plus D with,
Q minus.
because that's what P plus D is. So people get so focused on like, I got to solve for Y, and then I can plug this in place of Y. Whatever this is, you can replace it wherever you see P plus D. You can replace it with that, because that's what the hell it is. And why is that cool? It's Q. Because now I got nothing but Q's left up there. That kicks the ass in, right? So once I know what Q is, I can plug it in all these things. What's really cool is once I know what Q is, then I have these two equations that would have just P and D in them, and then I can use substitution between them. Now, what's going to happen, though, is something interesting. Well, let's see. What do we get for Q here? We get 2Q equals, add the 5, 20. So Q is 10. If I put a 10 there, I get P plus D equals 10 minus 5, 5. And then I got this I can substitute. All right. Let's stop there. I did it a different way on the answer case because I didn't even remember that was there. Yeah.
Can we do
Is that okay? That's one way to do this. There's a lot of, you could have just went ahead and started killing, pick the peas and kill it and kill them again, and you know, that normal standard way to do it. That's fine. You would eventually get there. Which one?
8B.
Oh, 8A and B we're going to do in class. I didn't feel like getting another piece of paper. So on the actual test, you're going to need scrap paper because I'm going to just not even give you room. I'm just going to do that because I have no idea how long of a problem you're going to make it. So you can do that on your own sheet of paper, right? That problem. That's why it's the same thing as this. So on 8, is he still going?
Yes.
Okay. I didn't have time to dump my earlier video, so we're probably going to run out of space.
Because it has to divide by everything. I got one column.
So 8B?
Yes.
Okay. So the matrix. So just to jump to the chess. I really hope I made a problem that has an answer to that else.
I feel like I always pick the one column and I get stuck after that.
All right, so help me out. What'd you do?
Do you want me to just tell you what my numbers are where I got stuck?
No, tell me what you did. What'd you do first thing?
So the first thing I did was multiply row 1 by 2 and then added that to row 2.
I like it. So you multiply row 1 by 2. That's twice row 1. Added it to row 2. That makes a 0 there. Sounds beautiful.
So 0, and then I negative 3, 9, and 12.
0, negative 3, 9, 12. I like it.
Oh, I could have divided right there. I didn't
Yeah.
do that.
And then what else can I do? I can use that 1 to kill that 5. 5. If I multiply the first row by... How do I kill the 5? I multiply this by negative 5. Right? I'm done with these guys. So we multiply by negative 5. We get negative 5, 10, negative 20, negative 40. And again, you don't have to cram it all together. You could write the whole rows down and add them together, whatever works. So then I get 0, 11, negative 23, and negative 34. Now, I'm going to try, all right, I'm going to create matrices where you don't get to a point where it's really like, I can't make a 1 and these are giant numbers. I don't want that to be the reason you make some mistakes. Here, you don't have to try to do something like you just pointed out. Alyssa, what can you do with the second row? Divide by negative 3, and you made a 1 right there that you can then use to kill shit around him, right? You guys see that? Divide this row by negative 3. Leave the first row alone, leave the last row alone. What happens in the middle row? 0 divided by anything is 0. Negative divided by negative 3 is 1. 9 divided by negative 3 is negative 3. 12 divided by negative 3 is negative 4. Now I can use that 1 to kill those two things. The same way we use that one to kill those two things. Try to do the next step. Or maybe the next 2 steps. Finish that middle column out. And just to make a point, you could have started with that 1, multiply this by 3, killed this, multiply this by negative 4, killed, or you could have started with that 1 or that 1. Doesn't matter which column you pick to do first, just finish it before you move to the next one. Right? Finish it. Duke. I need to play some video games. So how would you use this 1
Multiplied by 2.
to kill that? Yeah, if you multiply the second row by 2, you can make a 0 here. Notice also that that 0 will not screw with that 1. That's why you finish a column out before you move to another column. So if I multiply twice row 2 added to row 1, put the answer in row 1. So twice row 2 is 0, 2, negative 6, negative 8. 0 plus 1 is 1. 2 minus 2 is 0. Negative 6 plus 4 is negative 2. Negative 8 plus 8 is 0. Then I can leave this guy alone. Let me not try to cram too much in there. Let's see. And how do I kill the other piece of that second column?
Multiply
Negative
row.
Yeah, we'll multiply this by negative 11, so when I add it to this row, I'll get a 0 there. Just always slowly marching towards that goal. Make a 0, go to the next, make a 0, go to the next, make a 0, I'm done yet. So now we'll get negative 11 row 2 plus row 3. So negative 11 times this is 0. Negative 11, 33, 44. So now I get 0 plus 0 is 0. Negative 11 plus 11 is 0. 33 minus 23 is 10. 44 minus 34 is 10. Sweet. All right, Jeff, you don't have to yell, man. I'm sorry. Yes, ma'am.
Could you do the same thing with row 1 instead of row 2? Minus up to minus 11? You have to use row 2.
Well, there's a 0 here. There's no way I can make 0 become negative 11 to kill this 11.
Oh, okay.
Yeah. So it's all about, okay, that 1 is here. I can use it to kill stuff around it. This 1 was first. I could use it to kill stuff below it. That's the main idea. Yeah. And then, of course, here, what can I do?
Divide by 10.
Yeah, divide by 10. Let me just do that because I'm getting tired. Divide that third row by 10. And now I got this 1 to kill these guys. Let me write this up here. It's getting a little low down there. So now if I multiply, I can multiply this by 3 and by 2. Is that cool? If I multiply by 3, I can kill this guy. Right? If I do this plus this, 0, 1, negative 3 and 3 is 0, negative 4 and 3 is negative 1. And then if I add these, 1 plus 0 is 1, 0 is 0 is 0, negative 2 plus 2 is 0, 0 plus 2 is 2. Now I can see my answers. So, I mean, it's the same answer for 8A. Just there you would do it. Kill an X, kill the X again. You got to pick a letter, kill it twice. That whole process. You guys doing all right? You're like, no. Shit. Remember, the thing about matrices, I know that there's a million places where you can forget a negative, or you can put a 2 instead of a 5 or something. I will pick up on those. I will grade you on, do you understand the steps and how to get to where you need to be? Right? If you can't show me that, you'll lose a lot of points. If you can show me that and you make a little negative mistake or something, you're going to barely lose any points. You just got to show me you understand what you're trying to do with this matrix. Somebody's there like, that's exactly what I have trouble with. Okay, then, get help. Get some help. Anything else from the practice test, homework, whatever? Quiz corrections you do tomorrow? Yes.
Oh, C. On C, when you go to factor it.
C.
Oh yeah, 6C.
6C.
Yeah. So when you have the parentheses with two different like.
So here's what I suggest. When you group things, don't use parentheses to group them, because that leads to a lot of weird shit. So I would say there's nothing in everything that comes out, right? So you group these. What comes out of these two?
X squared. X plus 2.
So then you know exactly what to take out of here. You need an x left in here. So you have to take out a negative 9.
Oh, okay. Well,
So that becomes positive x, and that becomes positive 2. And then thank God those are the same. Now officially there are 2 more steps to this. We've only learned enough to do 1 more step, officially. So the last step here would be what?
X plus
Yeah, the x plus 2 comes out. Some of you guys might know how to do something with this guy. I'm not going to... If you stop here right now, you're fine. On the next test, you're not allowed to stop here, because then we'll know what to do with this. But that's when we talk about 2 terms, squares and cubes. What if I give you the key? Let's see if that spurs things.
Are you ready?
Say again? You need a blank one? A blank practice test, or what do you need? That's what I'm saying. I ran out. Oh. Yeah, you're okay. You're okay. Don't worry. Yes.
I just have questions on my first question. So when you put all, you know,
Add.
oh,
Sorry. Yeah.
never mind, then I think I've done all my, they're just trying to say,
Yeah.
okay.
Yeah.
I thought you said all, I was like, I was like, what is he doing all?
This one. Do you want us to add? Do you want us to add each other? Like 42 and
You're not. like terms. I have 12 m squared x cubes. Do you have any more m squared x cubes?
Oh,
See, that you can only condense them if they are alike. Sure. Oh, no. So remember, when the bottom is just one term, you can break them up. This is still just one term. That over that, what's that over that, what's that over that, and then reduce. So much better, yeah. No, all at 5. 6, 1, 6, 2. Just remind you guys, the test is chapter 5 through 6.2. So you don't have to do 6.3 homework yet. You can stop the 6.2 homework for the moment. The next test is going to start at 6.3, so whatever. Yeah. 4x squared times x is negative 49. 4x squared times negative 2 is negative squared. Change the sign. You gotta multiply this by this. So you get 1, 2 terms. Cool.
why this is not the 50, Is it because this is negative?
No, it's because it's not the highest degree. That's the highest degree. So 1.
Oh, I see. You
The
always
leading coefficient is the one in front of the highest degree. Chapter 5 through 6.2. All right, I'll work my way around. Oh, yeah, so look, we've done stuff like this before, to be honest. If you put in your graphic down there, y1 is 4, y2 is this. Yeah. You do that first, I'll be right back. You do y1 equals 4x, and y2 equals x squared plus 3. So if you took an x plus 2 out, you're left with x squared. Yep.